The science of AV. Physics matters more than marketing when it comes to designing a great space and a great AV setup. Marques, you were just telling me a story, and I want you to recap it for the listeners, because sometimes the dreams that we have sound simple enough, but if you don't know the science or the physics behind what we're doing, it can be, it can't make sense. It needs to be redesigned. It's not that simple. So this is an episode where I want you to go ham on the science and the physics of AV. Tell us about this story, this problem you were trying to solve, and all of the equations and the physics behind what you were doing.
Yeah, absolutely. Again, math is 100% more important than marketing when it comes to an actual product that you're going to use and it's going to work. But we have a client, long-standing client, higher education, and we have this tiered classroom. They want to, do an upgrade, and they say, hey, one of the things we want to improve upon is we don't love the aesthetics of microphones and tables, right? And I'm not going to lie to you. To this day, we don't understand why, but students will destroy a microphone on a table. They will pick at them. They will break them, no matter what level of education we're talking about. It could be graduate students. It could be undergrad. It could be high schoolers. If you put a microphone on a table, it gets destroyed. So we said, okay, we'll do everything in the ceiling. Common practice in our industry is we have what we call voice lift, right? So there's voice lift and there's voice reinforcement. Different, mathematically different, scientifically different. The easiest way to think about it is when we're talking voice lift, it's, me and you sitting, we're having a conversation. Okay, so say that comes around 68 dB on average, just conversational audio levels. Well, now you're going to move 30 feet away from me across a room, but I want voice lift only, so it still feels conversational. So if I'm just talking, to the professor, for you, your experience will be as if I'm sitting beside you and you're hearing me at that level. So we fast forward, we have a client, they have a classroom, typical auditorium style, tiered seating, students and desks. And they say, hey, we want to implement a voice lift system. So we can capture, we can stream, we can do all these things in this room. It's an advanced AV over IP system, all the cool things. So we say, okay, we start really thinking about the science behind this room and how we're going to do this. So we're looking at it and I'm saying, this is very interesting because it's not acoustically perfect. No space is generally, just not what happens when you're building a room. And as we start looking into things, I say, hold on, let's pause for a second. Voice lift's totally doable. But as I'm looking at the surfaces, it's got windows, some hard surfaces from the desktops. So this could be a little bit of a challenge. So for everyone out there, if you're going to do voice lift, PAG, NAG is your friend, right? PAG is potential acoustic gain. NAG is needed acoustical gain. And it's an equation you can do. There may be some calculators out there that can do it for you. But basically, as you're working through this, you can figure out, okay, is it even possible for me to get the amount of gain I would need out of this microphone into these speakers without the room going into feedback? And if you've ever been out if you watch a football game on TV, as soon as the ump turns on his microphone and you hear all that squelching, that's feedback in case you weren't familiar, for anyone out there. You don't want that in a classroom. You don't want it in a meeting space. You try to avoid it. So to really pull this off, we start thinking more and more about it. One manufacturer did suggest I avoid this. They said, hey, Marques, this is not going to work in that space. We've already checked it out. The heights are not good. We'd advise you not to do this. I said, okay. I am always one to listen to others. There are lots of people smarter than me out there. I love to get all the feedback. The other part of me says, how do I know I can't do it? Are we sure? So we're talking amongst ourselves in our design team. Shout out to all the members of our design team. It's great because we can throw out ideas out here and someone's seen it or done it, so we work together on it. But it really got back to just sitting down. I went old-fashioned. I kind of got a paper, digital paper in this case, I was on my computer, kind of sketching the room, figuring out where the speakers, figuring out where the microphone is going to be. Well, then back to this PAG-NAG equation, I have to calculate, between every speaker, every seated person, okay, what's the distance between them and the farthest other person? Where are the speakers located? And there's a great graphic. One of our manufacturers has a great graphic to really help understand what this looks like and what it does. So the fun part about it is there's also change in height in this equation in the room, which makes me have to do a calculation from every seated position almost in this room. So we go back and we're breaking this all down, and I'm working with the manufacturer to just double check my math. And they say, Marques, sure, it looks good. Not super reassuring, but I said, okay, But no, I mean, and essentially we end up designing the system where we calculate it all out. We get it in place. We do these, microphone array systems. We have speakers that we end up turning every individual speaker into its own zone. So those that do mixed minuses will understand that really quickly. So you can send audio out of certain speakers, but not back to its own zone, and it gets wild fast. But imagine a classroom where you have, 18 speakers in the ceiling. Normally they're all one big group, maybe a few zones. Every single speaker is its own zone. Every lobe from this array is now routing to a certain area of the room to capture it, and now routing out of the other speakers. And it took some tweaks. And once we were done with it, we brought in the manufacturer remotely. They checked it out. I was working with one of our field engineers at the time, and we got it dialed in, and it's working perfectly. And the client is, over the moon. They love it. There's some rules and caveats because, again, with the height change in the back of the room, if you stand up, you're probably 3 feet away from the microphone. In the front of the room, you're standing up, you're 11 feet away from the nearest microphone. So there's just a lot of math we're doing behind the scenes as far as gain structure at every single microphone position, making sure we have the routing correct. And of course, we're mixing in things like, well, of course, we're doing a Dante because why wouldn't you? We're digital audio all the time. So are we routing it correctly in Domain Manager? Are we able to capture it back to the recording studio area where they can actually see all of their classrooms? So finish the project off. It's working great. A few tweaks here and there, just once we can get it actually in use, get it full of students, see it in action. But it's one of the more challenging deployments, and it all came down to math, right? It just came down to sitting down, sketching it out, calculating it. And there's no way to cheat this, right? People will say, well, you just throw it in AI nowadays. No, you can't. If you're going to put it in AI, you have to double check every calculation because in our industry, there are companies that are working on it, and we internally are also working on it. Can I, build my own agent using the specifications that are unique to our industry? And it's not quite there yet. So if you really want to be right, even if you do build your own agent, you have to double check all the calculations right now just to make sure it doesn't, go off on a wild goose chase or I think the term is a hallucination. Say you don't want any hallucinations because that will really throw off your work. But yeah, and it all came down to math because if you read the brochure for these microphones, all day long, oh yeah, you can do voice lift and it's great. And they could do all these things and just put them anywhere. And here are these case studies, and people missed it. That's the marketing. Behind the scenes, there is a lot of calculating and making sure that this is going to work before we actually, just turn this loose to the client and deploy it in the field. So what we're trying to do is going to be successful. And again, at the same time, it has to be easy, right? We can't have a client needing to adjust levels or turn this one up, turn this one down. You have to be able to put all the automation in place to make sure this room, when they walk in and they start talking, it just works. That's it. They don't need to do anything with the audio system. If my professor's wearing a lapel mic, I have to calculate for that to make sure that's not going to interfere with my, voice lift system. So all these things are happening. We're applying ducking and all these cool features in AV. But that's what has to happen because, again, as a professor, I'm here to communicate to students. I'm here to teach. That's it. I'm not here to fumble around with connectors or levels or any of that. So that's why it really, really matters. Math and physics, they are undefeated. You can bend, you can cheat, you can kind of, edge things right to the edge, but they always matter.
What you're getting at is simplicity. Simplicity is elegant, but simplicity does not mean easy.
It does not.
To do everything you just described, that is a full team, that is a lot of planning, that is a lot of intellectual activity, plus physical activity, lifting these things, doing all these things, designing correctly. This is not easy. And something that you've talked about before is to bring your team in as early as possible in the process because you need to be thinking about these things in the architectural phase and even before that. Like, tell us the dream, let's sketch it out and figure out what needs to happen because you've said before that architects they're not audio engineers, acoustic engineers. Like they don't think in terms of the acoustics like you do. And so I'm thinking of your sketch, correct me if I'm wrong, but what I had in my mind was, in those kids' toys, you like put your pencil in the center of this thing. It's got all these like grooved teeth and you kind of like move your pencil around and it's got all these like cross hatching and angles. That's what I'm imagining. That's what I'm imagining. So talk to us about where is it like in the phase where you would ideally want to do this on a project? Because like you said, architects aren't, they're just not thinking in this way. how do you come in on this project to be thinking about how the room would be set up because you've got to put holes in the wall for cabling and where the speakers will go and the mics will go and all that kind of stuff. Like, when is the best time to be thinking about this kind of stuff?
Absolutely. The second a client says, hey, I want a new room, I want a new building, what ends up happening, in this particular case, we're retrofitting a space. So it's a little bit different. But when we do work with an architect and we're going to do a net new build, the second it happens, and we have some great partners. I don't want to leave them out on this because they always bring us in really early, and that's what we appreciate. But the second we're doing, programming in the architectural phase, getting into schematic design, that's when we want to be at the table because we have to hear, like, what exactly are you trying to do in this space? Mm. We have another client. They have a gorgeous office space. They have a conference room. It is really warm. It's, wood and, marble countertops and, all these glass walls. The problem became because they said, oh, yeah, this is our primary conferencing room. And immediately we said, hey, when you say conference, we assume you mean Teams, Zoom, Google Meet, what have you, microphones, speakers, hearing people, right? They say, yes. I say, well, Houston, we have a problem. We have to have some way to use acoustic techniques to dampen audio reflections in this space because if you build one, and we've gone through this more than one time, right? We had one where we did a retrofit. It was already built. We walked in. I said, hey, I bet money that none of your web-based conferencing goes very well. They said, no, it's pretty awful, Marques. I said, yeah. They just looked around and we're like, yeah. Again, physics and math, they just are what they are. And
yes.
the physics and math, once you get the hang of it, you know right away. When you see something, you just automatically know. It was a glass room. Again, they had no materials to absorb or to refract or anything. So once the audio, think of audio as energy, right? Audio is just energy in space. So when it hits a hard surface, it's going to reflect. So now you have these reflections, and before that energy can dissipate, how many reflections are you creating in a room? And that's where, the science of acoustics really comes in to understand how do we put carpet down? How do you put what they call, clouds and ceilings, which are panels that can, absorb or refract or do something so you don't have these reflections? Because this microphone I'm talking into right now, even if my ears can't hear it, this microphone does. And as it starts to reflect more and more and more, it's to the far side, so to your side of it, it just sounds garbled. And that's why we say, the room is 100% beautiful and 100% not usable for the use case. And so how do you...
Okay, I want to go into that. Okay, so this is fascinating. Okay, so you're walking into a space and you're like, wow, gorgeous. And anybody in the world would look at it and go, wow, gorgeous. And that's what you imagine. I want to sit in this space. I want to look out the window. I want a view. I want wall-to-wall windows and beautiful countertops and all that. And you're going, yeah, gorgeous. Except this isn't going to work. So what are you assessing? Is it like the angles of the walls, the materials of the walls, the height of the room? Like, walk us through your thought process when you walk into a space and potentially you do have to retrofit. Let's say you're not brought in early on the process, you have to retrofit it. What are you thinking through when you walk into a room like that?
Immediately. So coming up on the room, you already know. So for those that are in this industry and they deal with this, you already know what's going to happen coming up to the room because I can see into it. So this is glass. Okay.
Okay.
And people, even if you don't get in the weeds on the math, you inherently do understand when I explain it to you because you know what a reflection is. You see a mirror. So you kind of know, like if you're in your bathroom clapping and you're in front of a mirror, or if you're in an all glass patio, you hear what's happening as your clap bounces around.
Well, that's why everybody walks into like a shower or, big shower and you start singing. Because you want to hear all the reverberations, or you go into a chapel or something, and you just immediately want to sing. I want to hear myself in this space.
It doesn't work for the technology, right? Your technology cannot overcome physics. So I go in, first thing we see, okay, I see all glass walls. I don't see any acoustic treatments. So like behind me on our wall, we have acoustic panels. I don't see any panels. Okay, well, that's tricky. Do we have carpet down? Right? Because there's an actual equation. I'm not an acoustic engineer, so I'm not as deep in those. I know about them. And there's a certain amount of surface area that needs to be covered to make sure you can reduce these reflections. And there's something called RT60, which judges the decay time of audio, from a burst in a room. These are just, again, they're mission critical because if your audio decay is not happening fast enough, that means the microphone is picking all this up. It sounds garbled, it sounds echoey, it sounds, all these things are happening in your system. And as soon as I walk up in the room, again, if I see glass everywhere, okay, we have a problem. If I see just really hard surfaces, you have a giant marble table, you have hardwood flooring. If you have an extremely high ceiling, open ceilings and all that stuff, like, yeah, that's cool. But, if I see HVAC running through the room, if I can hear your HVAC, because if I can hear it, your microphone can hear it. So now I'm fighting the HVAC level, right? We've seen rooms where the HVAC level, I literally have an app on my phone so I can always pull a measurement in the room. But if your HVAC level is above, say, 38 dB, there's what's called a noise reduction coefficient that tells you where it should be for whatever your task is. But I've gone into rooms where the HVAC is registering, 58, 65 dB. Well, if you're already registering HVAC noise in the realm of conversational audio, Houston, we have a problem, right? So as soon as I walk in and hear it, I say, hey, before we go any further with your technology, let's have a conversation about your room. And we caution people all the time, I can't sell you something that's going to fix the acoustic issue that you're facing. So if your HVAC is, one client, their HVAC was registering probably 68 dB. It's like, this is insanity. There's something wrong here. And I think in their case, they had a hole or they had something happening. But if you don't fix that, now you have to talk and try to be louder than the microphone. But guess what? What am I going to do? I'm going to gate the microphone, which is, you do a digital, it's literally what it sounds like, a gate, so it opens and closes when a certain amount of level is detected. Am I going to do that? Well, guess what? When you're talking, it still hears the HVAC. People say, I'm going to use the EQ and filter. You cannot filter out everything. If you try to filter out everything, well, you filter out the human voice, and now people say, it sounds tinny, it sounds robotic. Yes, it does. There's too much EQ being applied, right? So as we just walk in the room, we're gauging total height. Is it open ceiling? As I look around, are there reflective materials? Is there anything that's going to absorb material? How far away are people sitting from the microphone? That's one that gets people all the time. They'll say, hey, I'm on the website, and it said that this, all-in-one bar, it's good for at least 20 feet. And I just kind of laugh. I said, sure, if you had a perfect room. I haven't seen one yet, but if you had one, then it probably could be good if your furthest seated person was at 20 feet away. I said, but in reality, and we've actually tested this. We once did a test with an audio bar, and we marked our floor, and we had seats at, 5, 10, 15, 20 feet, so we could actually capture it in real time in a real room, and you could see how much the drop-off was in terms of the audio quality going outbound. It's like, yes, I know that it says that, and the brochure says, it's a really beautiful brochure, nice picture, shows your
I know what you're talking about.
Oh, yeah, shows all that. In the real world, again, this is just physics. So when you have a real room, and all these things are happening, it doesn't work. And so that's when you tell someone, it's when the price changes, right? Because they're thinking, I'm just going to use all-in-one bar. No, you're not. Not if you want to work.
I've had that exact thought. Because I'm thinking, because I was in this conference room at an employer of mine, and I was like, man, we have got to fix this. It is terrible audio when you're on the other side of it. And I'm like, but, it's one of these major tech brands has one of those bars. It's got a camera on top. It's got the bar. You can do speakers and mics, and the marketing is that, oh yeah, man, for $1,000, you're going to fix all of your conferencing problems.
You're not.
And I'm like, this is great. This is like a no-brainer. I'm glad I didn't purchase it, because you're saying the math is more important than the marketing. So
math is better than the marketing.
Okay.
And we're not anti, all-in-one bar. We sell them, we install them. They have a use case.
We're also not anti-marketing, okay?
No, yes.
To be clear.
We're not anti-marketing. Marketing is great. Otherwise, I wouldn't be on this podcast. So, yes.
That's right.
Marketing is very, very critical. All we're saying is, there has to be, and your average user is not going to understand this, right? So, to your point, I see the bar. Oh, it says it's going to be great. It says covers 20 feet, 30 feet. You're not necessarily thinking about, okay, well, how far is it? How are you sitting? Where are you located? What other audio sources are competing with this same, with my voice? Because again, if I just walk in and I hear your HVAC, I already know that's an issue. I already know that right off the bat, before I've done a single measurement, hey, this is something we have to be cognizant of, because keep in mind, the microphone is going to work better than your ears. Especially for a lot of people that have some, hearing loss or what have you, microphones don't have that. So they're hearing everything happening in the room. If you have microphones on your desk, why we don't do them? You have the table tapper, the person in the meeting that's tapping the table. They're ruffling the papers. Snack time, I want to open my bag of chips. All of that is going into the microphone. So it's just like, hey, let's move them up into the ceiling. Okay, well, is your ceiling at 9 feet, 10 feet? Perfect. Oh, wait, you have a feeling that's 20 feet. Well, I can't go that high. I need to make sure I get this microphone down, so I need to hang it. Now you're talking about aesthetics, right? Because, well, I don't want to see your microphone hanging down. Something has to give somewhere, right? To really have a quality experience, because if I have the mic too high, can't really capture like I need to. Again, physics. The closer you are to the microphone, the closer the source, being the human, is to the microphone, the higher quality audio you're going to have in almost every single case known to man. But there's cool microphones out here that, they can do all kinds of things and arrays and beam forming and whatever term they put on them now. Great, but there's still limits to it, right? So you can't just put them in any environment and think, if I hang a microphone that's 15 feet in the air and I have it competing with HVAC, and HVAC is right beside the microphone, or if I have, say, an older projector, it's got a fan and a lamp, it's making all this noise, if I put that right beside the microphone, okay, and now I'm injecting noise directly into the microphone. And again, that's just understanding what's happening in the room.
Okay, so let's say, it's very popular nowadays for people to have like an open concept and that industrial look, so let's say you got this room and it's got concrete flooring and it's got that marble, countertop or that kind of, enamel table, and then you got high ceilings with like the HVAC, you got that open ceiling look. What do you do, like, because that's like the in look right now.
Yeah, it is.
So it's like, okay, I need to like spray foam the ceiling. I need to put these little foam blocks in the corners. I need to get a rug.
There you go.
Like, what do you, okay.
All of those things, right? Because again, this is just math. You're trying to make sure you can reduce all the ambient noise. So what can we do to reduce that? You want to reduce any vibration from the HVAC, just the sound of the pressure, when the system's pressurized, blowing through vents, creates noise. So, okay, what can we do about that? Again, shout out to architects and their partners, MEP firms, because they'll go in and say like, okay, well, this is spec that it won't produce more than, 35 decibels. Okay, we can work with this, or 30 decibels. We can work with this. So all of that, if you're building new, is what goes on behind the scenes to check all those things to make sure that you're not injecting more sources of noise. But then once you do have those glass walls, okay, is there a film we can put up? Is there, something we can hang on the walls, start covering, a certain amount of square footage to reduce this overall reflectivity? It's just math. It's just equations to figure that out.
Okay.
And nowadays they have really artistic, beautiful looking, acoustic panels. You start dropping those in, try to put down carpet and do all these things, and that brings down your reflectivity of the surfaces. And now you start to get into the realm of being usable, right? Now we can start applying some technology, but then you get into the area of, well, what's the correct technology to use, right? And everyone says they have the correct technology. That's just what it is. You're trying to sell it.
Because it's marketing.
And sales, not just the marketing side. Someone's trying to sell this.
Fair. That's right.
But it really is sitting back, and some of it comes from experience of doing this so much. And, we have a philosophy of, if we're really not sure, we'll just build it in our shop and play around with it and figure out like, how is it? Is it okay or is it great? If it's great, let's roll. If it's okay, well, is there a way to improve it? Because we're not in the business of selling okay, right? I hope no one is. We always say we want to wow and delight as much as we can. So we have to really think about, okay, what's the right microphone? Not just what is the right microphone, where does it need to be? And how do we blend the aesthetics? Because we want you to have a beautiful room. Everyone wants a beautiful room, but we have to make sure it can work for your use case, or what's the point? Or you also get a lot of calls, right? If you have, unfortunately, a lot of AV calls get routed to IT depending on your environment. But what are you going to do? Oh, they're saying online that it sounds terrible. You're not going to fix that because you went wrong early, because you don't have the right microphone in the right space. Or we have, AEC, which when I came from the live space into the integration space, there wasn't a lot of AEC in live. It's not a thing you do. You do a mix minus, you're good to go. Come to integration, auto echo cancellation, and all this other stuff. But you have to think about that, because otherwise it's, getting the loop of the audio going back into the call, because now it's too loud in the speaker, the microphone's picking it up, it's being looped back, everything sounds echoey. Or if I'm on one side of it, I'm saying, oh, I'm hearing myself back. All these things start happening. Now, sometimes it's a case of, turn your speakers down, turn your own speakers down. But, if the room's not set up correctly and, you didn't design it correctly, you start getting more of that because you have so much energy going into the room, the microphone's picking it back up. But again, that's where AEC comes in. You start canceling some of that stuff out.
I can't tell you how many meetings I've been in a boardroom. Let's say I'm sitting where I'm sitting, it's a digital call, and then I'm talking to a team on the other end. There's 3, 4, 5, 10 people in this room. And we get on Zoom or Google Meet, and the audio is so bad I can't hear anything. So they call me. They put their phone in the middle of the table, and then so we have a phone. I'm watching the video feed on one end, and there's a phone that I'm talking to on the other. And that is so common. I've done that probably 100 times because you can't hear people.
Yeah.
And this is fascinating.
It's a very real thing, and people just don't understand. It's, again, preparation, math, planning. It's so critical to understand what is that room used for. And sometimes, we get into situations where there's someone driving a project. Did they even talk to the end users at all? You'd hope so, but if they didn't bring them to the table to understand the workflow and what's actually happening, sometimes they're copying like, hey, we did building A, we're setting up a new building, we're just going to copy building A. Well, do you have the same users? Do you have the same workflow? Do you have the same needs? It's just technology changes. Every week we're getting some brochure about some new doodad that does everything you need to do. But it just kind of gets lost in transition. And then there's actually more capital lost in more areas than what people think about. So yes, you've invested all this, in these buildings. And, when we see whole buildings going up, you're talking about potentially millions of dollars in audiovisual technology going into the totality of a building. So if you think about this and what really goes on behind the scenes, say I'm a facilities manager, I've hired a company, I've done all this, we've spent $1 million. Now you're telling me the spaces aren't working correctly. Okay. Or every week I'm spending time running into a room. I'm trying to reboot. I'm trying to help people connect. I'm trying to, do whatever it is I have to do to try to get the room to work. Okay. Well, now that employee is spending how many hours every single week fighting a room, trying to make it just do what it's supposed to do. Okay.
Yeah.
Well, also go to the user experience side. Even if the room in theory is working, to your point about the not great audio on the call. Okay, well then how many people get tired of that and they say, every time I have to use this room, the audio is just terrible. I use my phone anyway.
Yeah.
Well, now you've lost trust of, I don't trust the system, or I'm trying to make adjustments, or I'm not using it the way it was meant to be used. And I don't know what to do.
Or the relationship. What's become important to me is there's so much that is so important about relationships and the way humans communicate and the timing, a joke or catching that. There are so many times in conversations that like, oh, I didn't quite hear you because either the internet cut out or the audio or the echo, whatever. And those little grates over time, they're very, very slight, but they add up and it makes either the relationship tense or what you're saying that like people just don't want to use the room. And so then you just have these like breakdowns of these tiny little things that I know everybody listening knows exactly what I'm talking about, but that kind of thing, I started to really pay attention to that. And I've actually been seeing people more in person because of those little breakdowns. They're like friction in a relationship, and it's starting to drive me crazy.
It's fatigue, right?
Because I really value that. Yeah, exactly. It's fatigue.
It's meeting fatigue, because if it's not dialed in correctly, even little things like we talk about latency sometimes, right? If I have to have that awkward pause to make sure you're not talking and then you can't quite get it just right.
Yes.
All of that comes in, and it's like, hey, here's a pro tip. It's like, hey, you need a certain amount of bandwidth to have a Zoom or a Teams meeting. A lot of people don't know this. It's like, you can't just run a Teams meeting off 2.5 megs of bandwidth. Not going to work out very well for you. The more screens you have, if I have, 3 displays and I'm sharing and I'm doing all this stuff, you probably need somewhere between 5 to 10 megs of bandwidth, which seems simple. Okay, well, what else how much bandwidth do you really have? How many rooms are we talking about? How much bandwidth are you, eating through at one time? If you have 10 meetings happening across 10 different rooms, did you calculate all that? So, that's even something that people just don't think. I've thought about this in my home because, yes, I have, enough internet to make sure no matter what's happening, if I'm on a call, I have enough bandwidth, doing quality of service adjustments, prioritizing your bandwidth and all these things. But that's all part of what's happening in the background to set this up to have a quality user experience.
Yeah. I've been telling folks over the years, you should probably aim for like 30 megs a second in your download speed, at least. If you can hit that in your Wi-Fi, you're going to be pretty good on Google and Zoom and all that kind of stuff.
Well, uploading is what kills you, though, right? Depends. Especially when you start sharing and everything else. That upload, and if you don't have, bi-directional speed, I'm not gonna lie, I'm a lover of fiber. I have fiber and I appreciate it. Yeah, right. Same. If you can do it, it's the way to go, because I know I have the same thing up and down. I'm good. Back in the days, especially you start talking about dial-up and some of these other things. Sure, maybe you do have 50 megs down, but if your upload is 1.5, that's a nightmare.
If you got problems now, just get Starlink. Just get a satellite to beam it down to you. Just kidding. Okay, this is fascinating. I haven't told you this yet, but a couple episodes ago, we talked about cords and how you shouldn't get the $8 cord. Get the $80 cord. It's going to, don't buy the thing off Amazon. So because of you, I bought directly from the Apple store their Thunderbolt 5 cable, the top of the line cable. And it was like $60 or $70. And it's like a little 2-foot cable. But prior to talking to you, I would have never done that because I'd be like, it's a cable. It's just a cable. I get one on Amazon for $10. But
it matters.
You taught me it matters because I need the video, I need the Ethernet, I need I need everything to come into my computer. So
yeah, it matters. It's again, it's all again, it's math. It's does that cable support a protocol that supports the speeds you need for what you want to be doing? Because a lot of people don't think we talked about docks a little bit today and travel docks. Okay, that travel dock is using one port. Well, what protocol is that port using? Because if you think about what you're going to hook up to your dock, I'm going to hook up a camera, I'm going to hook up a microphone, maybe I'm hooking up a few other devices. All of those devices have bandwidth, and they start to eat through that bandwidth. And there's just overhead calculations you have to think about. Well, if all that's coming into that one port, that one USB-C port, what was it rated for? And what kind of USB-C port is it? So and again, that applies, we talk about the personal computer side, but that applies through all the technology we deal with when we're installing things.
Gosh, that would give me the biggest headache. I'm so glad there's people like you that exist because I can't fathom that.
It's a lot of training all the time. All the time.
Yeah. That's great. Okay, I love that. Maybe I'll fly you out to fix my Wi-Fi. My Wi-Fi isn't getting back to my bedroom, and I need that. So
anyway. That's calculations too. There's calculations for that.
Okay, I need to know this. Okay, Marques, any other final words? It sounds like you guys can come in at any step of the process, but at the very beginning is always the best because there's a lot of math involved. But at any point, even if you need to retrofit a room, you can still come in and do that. Is there any other thing that you would like folks to know that are like me and thinking like, man, I want this beautiful space, but I also want it to sound great? Things that you've learned over the years regarding the math and the physics of it.
Just always remember, math is real. Physics is real. Marketing is also real. I never want to discredit sales and marketing. Marketing will not overcome physics no matter how you try. It just won't. It won't happen. It's so just keep that, and always have an open mind, right? Discuss things early and often. I always harp on that one. Bring the right folks in early, and one thing I want to stress to people again: don't get into a race to the bottom. Right? It's not just about, can I lower the cost? Can I bring the cost down? And I get it. Everyone has a budget. No one, people don't have unlimited funds. Very, very true. But understand what are your needs? What are your wants? And what are your have-to-haves? What are I need it now and I'll add on later, and come up with a solid plan with a partner to get you, a roadmap to where you want to go, how you're going to get there, so you can manage that. Because if you're in a race to the bottom, you're going to pay twice probably in the life cycle of the time that where had you spent a little more or went with something more reputable, you would have spent it one time, and it'll get you through 5 to 7 years. Whereas, oh, wait, I'm going to get the lowest cost item I can find. Well, now you've replaced it 2 to 3 times in that 5 to 7 year period. And not to put on my environmental hat, but what are you really doing? Unless you make sure you e-cycle it every time, that's also contributing to waste. I see people with displays that say, "Oh, I don't want a commercial display." Okay, I can go to Best Buy and buy, 2 or 3 displays for the cost of that one commercial display.
Yeah,
and that's fair criticism, but again, when it burns out faster, if you can't control it, because they don't use control protocols the same way, and all these things are happening. Or someone once told me I can literally replace it twice, and I still would have paid less. I said, but again, you're throwing. I know you're not recycling them, so you're just going to a dump or a landfill with 2 or 3 displays in the time that you literally could have had one display working the whole time. So there's all these other things to just think about. Just, what's your impact on the world? What's your impact in your own room? Do you want something to just die randomly? Do you want to have a little bit more control of like, hey, this should make it, and no one's perfect, but it should make it 5 to 7 years versus when it goes, and we'll deal with it being down, and now we'll go change it out.
Yep. Honestly, because of you, I've thought so much more about these kinds of things. I came across this book that the legendary designer Dieter Rams wrote called Less But Better. And so in the terms of like capital allocation, resource allocation, I've been thinking like, I want fewer things, but I want those things that I have to be much better, especially if it's things that I use every day.
Right.
So I mentioned like the cable, any of my computer stuff or my display. Like I just am in this period of my life, I want the best of the best because I'm going to be using it every day. It's going to last for 5 or 10 years. You know, I'm not going to have to like upgrade every 2 years or throw things out. So yeah, you're talking like this has had a big impact on me, just even personally, just the things that I'm buying and paying attention to now, because I just want things that work.
Yep.
And I know if I buy the very high end thing from the very reputable manufacturer, I'm going to get the thing that I just plug it in and it works. And I don't have to download some kind of driver or whatever and figure out how it works. It just works. So
it's all about what's the experience you want to have, right? Are there there's steps in between? I tell people you don't have to have, you know, the Ferrari. You don't have to necessarily say, I just want the Civic. There's tons of things out there in between, but you know, what's the right fit for you? I just always caution folks, you know, if it sounds too good to be true, it likely is.
I like that. That's a good point to end on. Marques, thank you so much. I always love your wisdom and your expertise. And I knew coming into a show like this about the topic of the math of AV, I was like, okay, we're going to hear Marques at his best. So thank you for sharing with us. I know there's a lot that you and your team do to put these spaces together and make them really simple and elegant, but there's a lot of complex stuff going on underneath that people need to know about.
Absolutely. So, and we love it.
Thank you for sharing.
Yeah.
Thank you. All right, man. Well, we will see you on the next episode.
Great.